if u is a function of x and y is a function of u, then y can be differentiated with respect to x, denoted by dy over dx. The derivative of y with respect to x is equal to the derivative of y with respect to u, which is obtained from the derivative of this function, times the derivative of u with respect to x, which is obtained from the derivative of this function with respect to x. This is what we call the chain rule. Okay, and we'll call this the differentiation formula number 6, called the chain rule. So how do we obtain dy over du? From the derivative of this function with respect to u, that's dy over du, and then du over dx is the derivative of the function u in terms of x. Okay, that's the chain rule. The chain rule is actually used to differentiate composite functions. So let's say you have y as a composite function f of g of x, the composition of the functions f and g. Now if you want to get the derivative of y with respect to x, well, this is the other notation for the chain rule. It's actually the derivative of the whole function f of g of x times the derivative of the smaller function g. Okay, so this is the other way to write the chain rule. It's the same thing, but using different notations. Say for example, given f of x equals x squared and g of x equals, let's just have 2x plus 1. What is f of g of x? So that is f of 2x plus 1, right? So it's actually equal to 2x plus 1 squared. This is f of g of x, according to the definition of composition of two functions. So let's say this is equal to y. According to this formula, the derivative of y with respect to x is equal to the derivative of f prime of g of x times the derivative of g of x. Okay, remember this is g of x. What is g prime of x? G prime of x is 2 times the derivative of x with respect to x. So it's just simply equal to 2. Okay, so dy over dx, according to the second notation for the chain rule, what is f prime of g of x? This is, remember, this is f of g of x. Now what is that? What is the formula for that? Now it's f of g of x is a power of 2x plus 1. Okay, so it's a power of 2x plus 1. The exponent is 2. So to differentiate 2x plus 1 raised to 2, we use the power rule. Okay, so it's going to be 2 times 2x plus 1. So in the power rule, we bring down the exponent. Okay, the exponent is 2. Copy the base. The base is 2x plus 1. And then subtract 1 from the exponent, right? This is this part. This part is f prime of g of x, using power rule. Now, what is, so this is, so f prime of g of x is equal to 2 times 2x plus 1 raised to 2 minus 1. Now, what about g prime of x? G prime of x, as what we have obtained, is equal to 2. So that is equal to 2, okay, times 2. So this part is g prime of x. Okay, and so dy over dx, according to the second notation, is, well, we just have to simplify. Multiplying 2 and 2, we get 4 times 2x plus 1 raised to 2 minus 1. So it's just raised to 1, right? So simplifying that, we'll have dy over dx equals, we'll just distribute 4 inside the parentheses and get 8x plus 4. This is the derivative of y with respect to x. Now, using the other notation that dy over dx is equal to dy over du times du over dx, provided that y is a function of u and u is a function of x. I'll use the same given in the previous example, but this time we have to let y is in terms of u, right? Y be equal to u squared and u be equal to 2x plus 1. Okay, so the derivative of y with respect to x according to this formula is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, what is the derivative of y with respect to u? So y is a power of u, so using power rule to get the derivative of u squared, it's simply 2 u raised to 2 minus 1, or it's dy over du is equal to 2 times u. Now, what is the derivative of u with respect to x? It's equal to the derivative of 2x plus 1. The derivative of 2x is 2, and the derivative of 1 is 0. So du over dx is 2. Now, what is the derivative of y with respect to x? According to the formula, it's dy over du, but dy over du is equal to this, 2u, times du over dx, 2. If you have the notation dy over dx here, it means to say that this derivative must be in terms of x because of this. This is the independent variable. Okay, so dy over dx is equal to 2u times 2 is 4u, while u here, look at this given, is 2x plus 1. So in terms of u, it's 4 times 2x plus 1. Now simplifying by distributing 4 inside the parentheses, dy over dx is equal to 8x plus 4. So we get the same answer. So it's the same formula, but using different notations. Now, from the chain rule, we can generalize the power rule. So remember, the power rule is written in this way. So the power rule is for the derivative of the power of x only. So with respect to x, it's nx raised to n minus 1, right? This is the power rule. Now this power rule is just for a base x. Now for any base u, the generalized power rule would be written in this way. The derivative of u to the n. Now for any base u is equal to n, so still bring down the exponent, copy the base, this time it's u, and then subtract 1 from the exponent. This time you have to differentiate the base with respect to any independent variable. Say for example, in the previous example, u is in terms of x, you differentiate u here with respect to x. So the notation would be du over dx if you differentiate with respect to x. Okay, so that goes for any independent variable. So this is the generalized power rule. Okay, so it's just the power rule times the derivative of the base, du. Okay, just like how we used this formula, the generalized power rule, in the previous example on the left side. So let me solve again the function in the previous example using the general power rule formula and the chain rule. Say, for example, differentiate 2x, y equals 2x plus 1 squared. That's the same function in the previous example. That's on the left side of the screen. Okay, now using the chain rule. Okay, so we have to write y as a function of u. So what we'll do is let u be equal to the base 2x plus 1. Okay, in the chain rule, it's on the left side of the screen. You have the derivative of u with respect to x, and you have the derivative of y with respect to u in the formula. So since u is in terms of x, du over dx as what we have already obtained a while ago is 2. And then since u is equal to the base, y can be written in terms of u already. So that's u squared, since u is equal to 2x plus 1. Now, since y is in terms of u, we can differentiate y with respect to u. Using power rule, that is 2u. Okay? So by chain rule, dy over dx is equal to dy over du, that's 2u times du over dx 2. And then writing, so that's 2 times 2 is 4, the constants. And then writing u in terms of x, where we have obtained this equation a while ago, is 2x plus 1. Okay, so simplifying that, we'll get the derivative of y with respect to x equal to 8x plus 4. That's what we obtained a while ago. Now, using the general power rule, we can use the general power rule because the function is a power of 2x plus 1. Alright. Okay. So, the derivative of y with respect to x using the generalized power rule. So, it's a power, we are differentiating this function. In the power rule, look at this. You bring down the exponent, copy the base, 2x plus 1, subtract 1 from the exponent, and then what is this part? Du is the derivative of the base. Okay, this is the derivative of 2x plus 1. Okay, so simplifying, we'll get 2 times 2x plus 1 raised to 1. The exponent is 2 minus 1. The derivative of 2x plus 1 with respect to x is equal to 2. Okay, the derivative of 2x is 2, the derivative of 1 is 0. So simplifying that, multiplying 2 and 2, we'll get 4 times 2x plus 1. And then distributing 4 inside the parentheses, we'll get 8x plus 4. This is dy over dx. So it's the same thing using the chain rule and the generalized power rule, since the general power rule is also obtained from the chain rule. Okay, let's have more examples. We differentiate these functions. So number 1, f of x is equal to square root of 1 minus x. Okay, so whenever you have a radical in the function, write the radical using rational exponents. F of x can be written as 1 minus x raised to 1/2. So to get the derivative of the function, we'll simply make use of the general power rule. The derivative of f of x is equal to. So in the generalized power rule, we still bring down the exponent. So in this case, it's 1/2. And then we copy the base next to that. And then we subtract 1 from the exponent. And then you don't forget that you need to take the derivative of the base. So times the derivative of the base. The base here is 1 minus x. Okay, simplifying, it's 1/2 times 1 minus x raised to negative 1/2. What is the derivative of 1 minus x with respect to x? So the derivative of 1 is 0, minus the derivative of x with respect to itself is 1. So it's 1/2 times negative 1. We'll have negative 1/2. And then times 1 minus x raised to negative 1/2. Again, we don't want a negative exponent in the final answer, so we write 1 minus x raised to negative 1/2 in the denominator and get negative 1 over 2 times 1 minus x raised to 1/2. So in radical form, that's a negative 1 over 2 square root of 1 minus x. No need to rationalize your final answer. This is the derivative of f of x. Number 2, given g of x equals a power of 4x squared plus 2 raised to 3. Okay, You have a choice if you want to expand this. Raising 4x squared plus 2 to 3 is very easy to expand, but for larger exponents, okay, I'm sure you will not choose to expand anymore. So instead of expanding, we'll just use the generalized power rule to differentiate that function. Okay, so the derivative of g of x using generalized power rule is 3. Okay, that's the exponent times the base plus 2 raised to 3 minus 1 times the derivative of the base. Don't forget this. So it's equal to 3 times 4x squared plus 2 squared. Now what is the derivative of the base for x squared? The derivative of 4x squared using power rule, but we have to set aside the constant 4, right? Setting aside the constant and using power rule to differentiate x squared, we'll have 8 as the constant by multiplying the base, the exponent and the constant 4. So we'll get 8. X raised to 2 minus 1 is 1. So plus the derivative of the constant 2, which is 0. So what we have is 3 times 8x, and that is 24x, times 4x squared plus 2 squared. You don't have to expand anymore because anyway, the given function g of x is in factored form. So it's okay to write your final answer in factored form also. This is the derivative of g of x. Another example, of course, we can also have a function of another variable aside from x. So we can have f of t. So where the independent variable is t. So t plus 1 over t minus 1 cube. So this function is a power of the quotient t plus 1 and t plus 1 over t minus 1. So to get the derivative of f of t using the generalized power rule, you copy the exponent, bring down the exponent, copy the base over t minus 1 raised to 3 minus 1. Don't forget the derivative of the base, t plus 1 over t minus 1. Okay, the base is a quotient of t plus 1 and t minus 1. So to differentiate that base, you need to use the quotient rule. Okay. So it's 3 times t plus 1 over t minus 1 raised to 2. Now we go to the derivative of the quotient using quotient rule. So remember the quotient rule. It's like this. This is u and this is v in the quotient rule. So recall the quotient rule. Derivative of u over v is v du minus u dv all over v squared. So we'll use that formula to differentiate t plus 1 over t minus 1. Where u is the numerator and v is the denominator. Okay, so what we'll do in the formula is you copy v first. V is t minus 1 times du. What is du? That's the derivative of the numerator with respect to t. The derivative of t with respect to t is 1. Plus the derivative of 1, which is just a constant, so we'll get 0. And then minus, in the formula we have u, and u in the given is t plus 1, times the derivative of v, that's dv, which is the derivative of the denominator with respect to t. So the derivative of t is 1 again with respect to t minus the derivative of the constant, 0. And then all over v squared, where v is t minus 1 squared. Okay, so we're done with the differentiation process. What we need to do is simplify our answer. So 3 times, remember in this expression, t plus 1 and t minus 1 are both squared. So we have t plus 1 squared over t minus 1 squared. Okay? And then we'll have t minus 1 in the numerator, because t minus 1 here is just multiplied to 1, minus the quantity t plus 1 all over t minus 1 squared. Now this can be combined. This can be multiplied. This and this can be multiplied. Alright? So we'll have 3 times t plus 1 squared, alright, over t minus 1 squared times t minus 1 squared is 2, is t minus 1 to the 4th power. And then the numerator, this part, that's t minus t over here, and then a negative 1 minus 1. So that's a negative 1 minus 1, right? So t minus t is 0, and then negative 1 minus 1. And then this part is already here. Alright, now simplifying further, that's 3 times t plus 1 squared over t minus 1 to the 4th times negative 2. And multiplying the constants, we'll get a negative 6 times t plus 1 squared over t minus 1 to the 4th. Okay, this is the derivative of f of t. I'll continue in the next video.